All right, so ladies and gentlemen, today what we're working on is starting with some proofs, okay? So proofs are just using a statement to say why things are congruent. And I've used some of them in the past. So real quick, we're going to look at number 1 together. So you're given certain things and you want to prove that those triangles are congruent through steps. And a flow chart is one way to do that. We're also going to look at a 2-column proof, which is going to be your homework for tonight. So we are going to look at both of those things. All right. So let's go through the given. F is congruent to I. So if we just mark up our picture, F is congruent to I, that's a given information. We're also given that FE is congruent to IH. Now remember, if you guys just put one little line here or 3 little lines here, it's still saying they're congruent. I just picked 2. It was random. Just make sure you're showing that the sides are congruent to the sides. Okay, what else, if I'm looking at this picture, besides the given, what else is congruent? I don't know any of the sides, right? Do I know any other angles? You know FGE is congruent to, and I'm putting 2 bands there to show that they're different than this, IGH. By what? Why are they congruent to each other? Vertical angles, good. Vertical angles. Okay, and now we have 3 things. Are they the same 3 things? We have angle, angle, side. So I'm writing a little note to myself that it's angle, angle, side. Now right here I'm going to fill in this stuff. F is congruent to I by given. Okay. FGE is congruent to IGH by, we wrote it down, vertical angles. You can just put VA for vertical angles. What's my other given information? Yes? Sure. I also need to write in a different color, don't I? Is that really hard to see, that light blue? Okay. This is given. This is vertical angles. Okay. Now, what is the other given? We look up here, it's FE is congruent to IH. Okay? And then, what did I say the triangles were congruent by? Angle, angle, side. Angle, angle, side. Remember, if it's angle, side, angle, the side would have to be in between the 2 angles. Okay, let's try another one. Again, I highly recommend you put your phones down. You write down what I'm writing down. This is a little bit harder of stuff that we've done. Okay? All right. Number 2. Given that T is the midpoint of AB, what do we know, if something is the midpoint, what do we know about both sides of it? They're equal to each other, right? Because it cuts it in half. Okay? We know that angle BTO is congruent to ATO. Okay, so let's look at my picture. We're given that T is the midpoint of this. That means BT and AT are congruent, right? If T is right in the middle, cuts it right in half. And then we're given that BTO is congruent to ATO. Do we know if anything else is congruent? Is there an angle or a side of this triangle that's congruent to each other? We don't know that yet. We don't know that B and A angles are congruent to each other. OT is congruent to OT. Yeah, I'm putting 2 little lines just to make them different than this. And what is that called when, like, this is congruent to this? Reflection. Good. It's like looking in a mirror, right? Your reflection in a mirror. So it's true by reflection. So I'm going to write that down just to myself. All right. And then how are these triangles congruent? By what? Is it congruent by side, side, side? Is it congruent by angle, side, angle? Side, angle, side. Good. Side, angle, side. Okay. So now we're going to fill out this little flow chart. T is the midpoint of AB given. BT is congruent to AT by definition of a midpoint. We can just read definition of a MP. Then we're also given BTO is congruent to ATO. Okay, by given. And then we can say OT is congruent to OT by reflection, because it's the same segment. And then how are the triangles congruent to each other again? Side, angle, side. How are we feeling about this? Is this a little weird? It gets easier the more you do them, and we're going to be doing proofs a lot, okay, especially starting Friday. All right, let's look at number 3. Okay, it says MS bisects angle AME. What does bisect mean? You cut it in half, so both halves are equal or congruent, yeah. And then AM is congruent to EM. Okay, let's do this on our triangle over here. So if MS bisects angle AME, these two angles are congruent, right? Yes? Okay, and it says AM is congruent to EM. What else do we have? What else is congruent to each other up here? What? MS. By what again? Reflection. And so these triangles are congruent by what? Yep, side, angle, side. You guys like to say it under your breath, don't you? You're like worried you're going to be wrong. Okay. Let's fill out this flow chart then. The flow chart is not my favorite way to do it. I like the 2-column proof. And that's what you'll have for your homework, and we'll do an example. Okay, so I'm given that MS bisects angle AME. And then since MS bisects AME, angles AMS is congruent to angle EMS. Okay. Okay, and this is, sorry, this is not right. This goes here. Angle AMS is congruent to EMS. Angle EMS. This is by given. And this is telling me definition of a bisector right here. It's a lot of words, but it's definition of a bisector. And then MS is congruent to MS by reflection. And then the triangles are congruent by what again? Side, angle, side. Sorry to people in the back, I gotta move this out just a little bit so you can kind of see the whole thing. Okay, we're gonna do one more, and then we're gonna do a 2-column one, which I think makes more sense. This is just another way to look at it, though. Some of you are kind of visual thinkers like this. All right, number 4. AE is parallel to DC, and then B is the midpoint of CE. So let's see what we can do with this. AE, I'm going to put an arrow for parallel, is parallel to DC. Do those arrows mean they're congruent to each other? No, parallel. And then B is the midpoint of CE. That means these sides are equal to each other, correct? What do we know about parallel lines cut by a transversal? How about alternate interior angles? These angles are congruent to each other by alternate interior. Okay. Is there another angle or side that are congruent to each other? ABE, but yeah. It's congruent to CBD or DBC by vertical angles, right? And then these are congruent by angle, angle, side. Okay, so let's put this down in my little proof. All right, B is the midpoint of CE, that's given. That BC is congruent to BE by definition of midpoint. Okay. AE is parallel to DC by given. Then angles EAB is congruent to angles DBC by alternate interior angles. And then angle ABE is congruent to DBC by vertical angles. And how are the triangles congruent to each other again? Angle, angle, side. Questions about this? I know it's a little weird. All right, let's look at the fill in the blank. Let's do one together. All right, let's read the directions first. That's always a good idea. Okay. Show the given information in the diagram. Use tick marks to show congruent sides and arcs to show congruent angles. Show any other congruent parts you notice from vertical angles, sides shared in common, or alternate interior angles with parallel lines. Give the postulate or theorem that's provided, congruent side, 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 angle, side, angle, angle, side, or hypotenuse leg, and then fill in the blank proof to complete, in the blanks to complete the proof. Okay. So what's step A say? Okay, so what's my given information? I'm given that BC is congruent to DC. So I'm going to put a mark on them. I'm given that AC is congruent to EC. So I'm putting tick marks on them to show that they're congruent. All right, what does step B say? Okay, what else is congruent on here? Yep, these are congruent by, what are these called? Vertical angles. Okay, and then how are these triangles congruent to each other? Side, 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 angle, 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 side, or hypotenuse leg? Let's try again. Side, angle, side. Okay, let's fill in this proof then. First, it says give me the given statement. So that's BC is congruent to DC and AC is congruent to EC. Okay, my vertical angles, that's angle BCA is congruent to angle DCE by vertical angles. Okay, and then how are the triangles congruent to each other again? See, don't you like what do you guys like better? Do you like the flow chart better? You like this better? I feel like the flow chart made my brain hurt a little bit. I'm like, where am I looking? And this is like real clear and precise. Okay, so you have the rest of this to do in class. There are 6 of them. Remember, if you get lost, are you following these instructions? A, B, C, and D. Okay? All right.